All right, so 2.4, example 2, we are going to practice the product rule. Your questions on your test tomorrow are going to be very straightforward. No more difficult than what we're going to do on example 2 and example 3, okay? So we walk up to the problem. We see that we're taking the derivative of 5x cubed times cosine of x. That is the product of two variable functions. The 5, you can just associate it with the x cubed. Constant multiples do not have to count as their own function. You can just associate them with the closest variable function. Now, for multiplying two functions of x, we have to use the product rule, which is not just as simple as taking the derivative of the first times the derivative of the second. Remember, the product rule from yesterday says you take the derivative of each one of them, but only one at a time. If you have two factors, you're going to have two terms, right? And in each term, you take the derivative of one of them. Now, I like to start with the first one. So, you need equal if you work down. 15x squared would be the derivative of the first, times cosine of x just goes for the right on the first one. Plus, now 5x cubed just gets rewritten, times the derivative of cosine, which is negative sign. And remember, dot negative is perilous because you could mistake it for a minus sign of subtraction. And that's it. That's the calculus. That's as hard as it is. You've got two factors, and it generated two terms. And you took the derivative of the first one first and the second one second. The other two just go along for the ride. Now, of course, some algebra might follow, which involves cleaning it up. 15x squared cosine x. This minus sign, if you're astute enough and you have enough experience, feel free to bring it out front as you take the derivative, and it would require, in this case, just one less line of writing. Now, later on, if we wanted to use this, we might be able to factor out like a 5x squared, factor it, set it equal to 0, but right now we're not doing that. Any questions on that one? That one's done, yeah. So tomorrow on the test, that could be an answer choice right there. Any other questions on that one? We'll practice some more. Letter B, here's letter B. This one is more similar to what's on the test tomorrow. You have two terms, right? And when you see two terms, you get excited because you know that's twice as much fun. You could treat each term as its own individual problem. What was that? Well, there's two terms. Remember, terms are separated by plus or minus signs. Yeah, terms. So in the first term, take inventory. You have a 2x, which you could think of as one function, times the cosine of x. I personally like to add the grouping symbols, especially in the beginning as I'm learning how to do things, because they help me see factors. And then minus 2 times sine of x, but 2 is not a variable function, right? So I don't have to think of 2 sine of x as two factors at all. It's just one function, sine of x. So one term at a time. Let's do the first one first. And it's a product rule with two factors, so it's just going to generate how many terms? 2. All right, so the derivative of 2x is 2 times cosine goes along for the ride, plus 2x goes along for the ride times the derivative of cosine, which is negative sine of x. So again, that two-term thing right there was generated from that one term. Now we can focus on the second term, and remember, constants go along for the ride. So the derivative of negative 2 sine of x is negative 2 times the derivative of sine of x, which is cosine. So again, you'll see that the calculus is ephemeral. It lasts but a short while. It's one line. A little bit of algebra, though, might still be on the bone afterwards, so we'll go ahead and simplify. 2 cosine of x, that negative can come out front and call it minus 2x sine of x. And I got minus 2 cosine x here. So that makes it look a little bit prettier. But y'all see anything good happening there? Yeah, this is where we can use the word cancel. Those are opposites. When you add opposites, they cancel to give you 0. And then we just get negative 2x sine of x. So a problem like that, boy, that's a pretty answer choice tomorrow, right? It's hard to stop. It's one thing to know when to stop, but it's a harder thing to actually stop because you want to keep going. It's calculus after all. I get it. Well, on a multiple choice, you stop when you match up to an answer choice. Always simplify, combine like terms, bring combine like factors in each term, and then look to combine like terms. When we saw that those were opposites, we can add them. And right there, we're going to stop. Later on, when we use it, we're going to try and factor it. So once we set this equal to 0 later on, then you would set each factor equal to 0. But we're not doing that on this test. That is another test and another day. We're dealing with expressions right here. All right, let's give you another one to try. How about this one? If f of x equals 3 square root of x times sine of x times cosine of x, what is f prime? Now, I'll talk about this before I just let you loose. How many variable functions of x do you have there? 3, right? You can associate the 3 with the square root of x. That's your first variable factor, then sine of x, then cosine of x. Does the product rule work with 3 factors? Yes. All you do is the same idea. If you have 3 factors, you're going to have how many terms? 3. And you take the derivative of 1 factor at a time. So I'll let the 3 square root of x go first, times sine cosine. Plus 3 square root of x just gets rewritten. Now it's sine's turn. Put his derivative, bring cosine along for the ride. And the last and third term, then it's 3 square root of x, sine of x times the derivative of the third. So try it. You just go down the line. Every factor gets its own term. You take the derivative of 1 factor per term. And you just work down the line. The other things that don't get differentiated in that term, they get rewritten. You can't just exclude them. One at a time. Now, you always remember that you can rewrite before you start, and I saw some of you already doing that. Maybe at this point you don't need to rewrite it because you can mentally. Like I would call that 3x to the 1/2, and maybe add grouping symbols. And then sine of x with grouping symbols, and then cosine of x. So, again, the grouping symbols just help you see the factors. Rewriting something so you can use the power rule could be helpful. Don't call that line f prime of x, though, because you haven't BOTC'd yet, have you? Yeah. Try to use fractional numbers instead of decimals. 1.5 would be correct, but I wouldn't have that on a test. Yeah. Clay, the reason is if the fraction was a 1/3, you wouldn't want to have to write 0.333 because now it's not as accurate. Yes. Right. Those you just rewrite. Well, that's the derivative of the first. So now you're done with the first term. Now plus. You always string your terms together with plus signs. The only reason it's going to be negative is if the derivative includes a negative. And look, Colin, you did dot negative. Okay. Yeah, so otherwise, let's see. You
can make those.
Oh, yes. Now, a note about this. When you write cosine of x squared, the way you have it written is cosine of the angle x squared. You need to have either parentheses around the cosine of x or write it in the condensed notation with 2 in between the x and the 2. And that's the more portable version of it. Yeah, there you go. Yes. That's times. I'm sorry. This is all times. This is times. No, these are all times. Cosine squared x. If you put cosine of x squared, it's the x that's being squared, not the whole cosine. Yep. One at a time. 3 factors, 3 terms. All right, here we go with the first one. The derivative of f is f prime. 3x to the 1/2 becomes 3/2 x to the negative 1/2. Okay, negative. And then the other 2, just times sine, times cosine. You have to write them. You can't just leave them out. Now, I'm running out of room, so let me bring all this over here so I have room. All right, the next one is going to be plus 3x to the 1/2, or at this point you can write it back as 3 square root of x because it served its purpose as the rational exponent. And now it's sine's turn. You go, sine. What's the derivative of sine? Cosine times the other cosine. And then finally, plus 3x to the 1/2 times sine. And then whose turn is it now? Cosine. What's the derivative of cosine? Negative sine. And again, if you put dot negative, you are running the risk of making a careless mistake. So negative cosine. And again, that's it. That's the derivative. You have three terms. If we go through and clean this all back up now, that first one can become 3 sine x cosine x. X to the negative 1/2 can go down with the 2 as the square root of x. So that's kind of the nice cleaned up version of the first term. The second term, we can call it 3 square root of x. And then cosine times cosine. It's cosine squared x. Now, when you write it like this, that is not cosine squared x. That's cosine of the angle x squared. You either put parentheses around the cosine, which is required, or remember there's another way to do it. You put the squared right in the, oops, not the x, just the squared. You put it right there. And that's cosine squared of x. If you're going to use it, it's nice to expand it and write the whole quantity with parentheses. Same thing on the last term here. You got plus 3 square root of x. Oops, what can we do with that minus sign? That should be, yeah, it should be a sign. Yeah, thank you. I was going to say it doesn't work out. The derivative of cosine is negative sine. Good. So this becomes minus now. You can pull the minus up front. 3 square root of x. And then sine times sine is sine squared of x. So there you go. That's it. Now, believe it or not, there's also some other things you could do. But I'm not necessarily going to do that on the test. But notice that if you factor out the 3 square root of x here, you're left with cosine squared minus sine squared. And we've reviewed that identity more than once this year. That is not Papa Pid. That's actually cosine of, that's cosine of 2x. That's your double angle. So plus 3 square root of x cosine of, there's an x there, 2x. Okay? And you can even, if you wanted to, you could play around with that by multiplying by 2 and multiplying by 1/2 and use the double angle for sine. You don't have to do that on this test. Right now on this test, it's going to be something straightforward. You're not going to have anything with triple. Yours is going to be more like this one. And this one. All right, any questions on the product rule? F prime G plus FG prime. One at a time. 2 factors, 2 terms. The next one is called the quotient rule. And it's for taking the derivative of 2 variable functions that are divided. But first, the incorrect quotient rule, because it's so often done. The derivative of f divided by g is not as easy as f prime over g prime. You cannot just take the derivative of the top and divide it by the bottom. Doesn't work, doesn't work. The correct quotient rule does work. So we just call it the quotient rule. And here's what it says. The derivative with respect to x of f divided by g is not f prime over g prime, but rather that. Oh, yeah. That one looks a little bit more formidable than the product rule, right? But it does have a really nice cadence to it, just like f prime g plus fg prime. That's the product rule's cadence. This one is gf prime minus fg prime over g of x squared. gf prime minus fg prime over g of x quantity squared. Man, this one's a lot easier to mess up, right? Because if you notice, there's a minus sign there. And is subtraction commutative? Rhymes with go starts with N. No. No. All right, it's not. So notice the first term has to have the derivative of the numerator first. So you think of it now as a pattern, right? The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. That's a lot easier to remember, right? There's a better way. Let me show you. Yeah, this is a proven technique that's worked for years and years and years. We are going to call f of x, the function in the numerator. We're going to call it the high function, the HIGA function, because the numerator is, in relation to the denominator, higher, right? So it's like being in Colorado high, but in the mountains high, not in the city limits, in the mountains. Like, well, high elevation, all right? Now, of course, we don't need the GH at the end because those are just superfluous letters that don't add to the sound of the word. So we're going to get rid of the GH and call it high, right? And now it looks like it's trying to be friendly with you. Just ignore it. Okay? It's kind of awkward. It's the high function because it's the elevated one. Now, the bottom function we're going to call the low function because in relation to the high function, it is low. It's low. Now, we don't need that silly W at the end, do you? Because you can just call it low, L-O, like J-Lo, right? So it's a low function. It's in the denominator. Now, here's where it gets interesting. We have high over low, which is easy to remember. We're going to use our poetic license here, and we're going to change the low to an H-O, which now becomes ho. And so now we have alliteration going. We have high over ho. The high function is the top function. The ho function is the low function. So you got the high in the top, and you got the ho in the bottom. Okay? High over ho. Because the top was a high, and the bottom was a ho. And now that you have high ho, where else have you seen high ho? High ho, it's off to work we go. Hi ho, hi ho, hi ho, hi ho. And they're gone. They're at work now. All right, so that's why we use high and ho, because we're familiar with it from our youth. Okay, so you have high over ho. You have high over ho. Now, look what the quotient rule becomes when you call them high over ho. It becomes the ho-de-high rule. Here's why. The derivative of high over ho becomes ho d-high minus high d-ho over ho-ho. Now, what does d-high mean? It means the derivative of the high function. D-ho is the derivative of the low function. Now, you are not going to forget this. You just say it a couple times, you'll have it. Ho-de-high minus high-de-ho over ho-ho. Ho-de-high minus high-de-ho over ho-ho. Over ho-ho. Now, there is a way to mess it up. And someone in the BC who took the test did mess it up because they went high-de-ho minus ho-de-high over high-high. No. So if you come down here, you don't want to think of it as Mr. Wilson. You want to think of it as dyslexic Wilson. Wilson says high-de-ho neighbor. Dyslexic Wilson says ho-de-high neighbor. And y'all have no idea what this show is. Okay. I know what it is. Yeah, ho-de-high neighbor. And then what does Tim Allen say? Whatever. Yeah. So it's ho-de-high. Now, why do we have Santa Claus running? Well, it's off-season, not Christmas season. What? He's trying to lose weight because Mrs. Claus is a great cook. It looks like he shaves his legs. But why is Santa on here? Well, here's why. A Santa that's in a hurry only has time to say, ho, ho. Sorry, but I gotta go. Though I'll see you soon when rain turns to snow. So this is what Santa says when he is in too big of a hurry to say the third ho. He says ho, ho, all that other stuff, right? And Santa's so slow that you were well within earshot while he's running away to hear all this. But at least he's out there running, you know? So that's where the denominator comes in. It's ho, ho, or of course, ho squared. So ho-de-high minus high-de-ho over ho-ho. It's not high-de-ho. That's kind of like a greeting. It's the reverse of that. Here's another way to remember it. And this kind of helps people. You start with a ho, you end with a ho. Okay? And the hoes are in the bottom. Start with a ho, end with a ho. The hoes are on the outside too. See that? Start with a ho, end with a ho. You're surrounded all over. The hoes kind of are on the outside. Yeah, you got the highs on the inside. It works. Ho-de-high minus high-de-ho over ho-ho. One last way to help you remember it. It's called the what rule? Quotient rule. So quo-ho. Ho-quo. Maybe so. Now, as you start coming in after today, I'll greet you as ho-de-high. Not as high-de-ho, but as ho-de-high. Are you ready to try the ho-de-high rule? All right, let's try it out. Find the derivative of each of the following. We got y equals. You walk up to the problem, and you're like, ho-de-high problem, how's it going? We have a variable function divided by a variable function. Some people call that the quotient rule. We're going to call it the Hody-High rule. Here we go. Nothing needs to be rewritten. So the left side becomes y prime. And now ho is just x squared minus 1. D high is what? The derivative of the high function is 4. There's Hody-High. Now, let me back up here before I go to the next part. If you just put x squared minus 1 times 4 like that, how you doing? Not very good because you forgot your what? You forgot your parentheses. They're kind of important. That's a binomial factor. So there's Hody-High minus high, parentheses again, d ho. What's d ho? And what is it in this case? 2x. Good. So there's Hody-High minus Heidi-Ho all over ho-ho, or, of course, ho squared. Ho squared. Hody-High minus Heidi-Ho over ho-ho, or ho squared. Now that's it. That's the derivative. The fun is over. Now it's just a little bit of algebra. Here's what you want to do. You don't want to leave it like that. You want to combine the numerator and try to factor it completely, but it's only partially factored right now. So your first task should be, before you just expand it out, look to see if there's any common factors that you can pull out. I see a 2 and another 2 that I can pull out there and a 4. But aside from numbers, are there any variable factors I can pull out? Yes. I cannot because it's part of a term here in the first term. It's a factor down here. These do not divide out. This is x minus 1, x plus 1. If you factor 2 out of here, you're left with 2x minus 1. So that's not going to be the same factor.
Can we do it 4 over x squared? What about 2
Okay, there's two. If you wanted to split it up, you would go this term over that minus that term over that. You'd have to put them both over the denominator. That's not how I'm going to have it. And in general, we like it as a single term. The product rule generates 2 terms. This one generates 1 term because you know what we're going to be doing later on? We're going to be setting it equal to 0. And if it's a single term, now I can set the numerator equal to 0 and the denominator equal to 0. So keep that in mind as we start using the quotient rule. It does generate 1 term. If there's nothing common other than a number, we're just going to go ahead and expand it out. So the top becomes 4x squared minus 4. And here you need to be careful because you're distributing a negative from the left and a 2x from the right. So you're distributing really a negative 2x. And that's going to be a negative 8x squared plus a 4x. Now the denominator is already completely factored, so there's really no reason to expand it out unless the multiple choice answer has it. And I wouldn't necessarily do that. So now it's just a matter of collecting like terms. And you'll see now that you have your 4 that's common still if you wanted to factor that out. But that's it. That's what the answer would be on the test tomorrow if you had one like that. Hody-High minus Heidi-Ho over ho-ho. Hody-High minus Heidi-Ho over ho-ho. I will greet you when you come in the morning for the test, or in the afternoon, whenever you come in. I'll be here at 7 if you need extra help. I'll greet you with Hody-High. Okay? Yes. Hody-High minus Heidi-Ho over ho-ho. All right, let's try another one. I'll give you a bonus one here. If f of x equals 2x minus 3 over 4x plus 7, find f prime. Your test question tomorrow will be no more difficult than this one. Hody-High minus Heidi-Ho over ho-ho. 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 How many of y'all are decorating your Santa? No? No? Hmm. He looks like he has a bigger tan on your iPad than mine. Yeah, maybe not. Maybe it's just a projector.
Is it high? High D means high derivative.
No, high d ho means high times the derivative of the ho.
Okay.
Yeah. The d comes before the one you differentiate. D high means the derivative of the high. Just like d dx of, right? The d comes first. The previous one? Hody-High minus Heidi-Ho over ho-ho. Good things should happen on this one. Good things should happen. You should end up with a number in the top, a constant. Don't expand the denominator. There's really no need to do that. This one's a little bit shorter than the previous one, actually. Are you doing hody high minus hidey ho over ho ho?
Yeah.
Okay. Ho times d high minus high times d ho over ho times ho, or ho squared. That looks right? Yeah? Positive or negative? Yep. Good. Did you distribute 8x minus 12? 8x plus 14. Oh, that should be, you forgot to distribute this negative to that one. That should be plus.
Okay.
Yeah, and that's a real common mistake. It's a real common mistake. Whenever you use that hody high rule, that second term is always going to be a negative distributing from the left, and the d high, or the d ho, distributed from the right. This 8x should be, so you're distributing a negative there and a 4. So it should be a negative 8x right there, and your 8x's will cancel. Yeah. All right, let's see how it's done. Quotient, right? So f prime, there's nothing that needs to be rewritten. Ho times d high. Parentheses are important around the 4x plus 7. Minus high, d ho is 4, all over ho ho. Ho squared. This, believe it or not, is something students tend to forget, the squared. Don't forget that. Now, there's nothing common in the top other than a constant, so we'll just distribute, and we get 8x plus 14. And here's the one you don't want to take for granted. Remember, you're distributing a negative 4. So tell yourself that before you start. You're distributing a negative 4. So that becomes a negative 8x, and negative 4 times negative 3 is positive 12. You could be off by a sign there, and that could cost you the whole problem on a multiple choice question. Now your 8x's do what? They cancel. That's when you cancel to get 0. And you end up with 14 plus 12, which is 26 over 4x plus 7 squared. And that's the answer. Guess what some of the other answer choices would be?
25.
No. If you did hidey ho minus hody high, that's like having 5 minus 7 versus 7 minus 5. What would the answer be? It would be negative. So you're going to have a negative 26 over that as an answer. If you forgot the squared, there's going to be an answer choice without the squared. Or if you didn't distribute the negative, that's going to be a negative 12. 14 minus 12, it could be just a 2 in the top. So all of those common mistakes that you might make, those are going to be answer choices. But you know what? You're not going to make a mistake because y'all are going to be very diligent when you're doing this. Careful, yeah. All right, let's do one more problem, and then we'll talk about the test. Bless you. F of x equals sine over cosine. Almost. You're not done yet. All right, we have a quotient. It's sine over cosine. So f prime of x is going to be ho times d high. What's the derivative of sine? Cosine. So that's d high minus high. What is d ho? Negative sine x. Good. And then all over ho ho, which again you can write like this. Is that cosine quantity squared? No. Put the squared there. Now in the top, you get cosine times cosine. That's cosine squared. Minus times minus becomes plus sine squared of x all over. And if you write the cosine squared directly under that one, you can add. Good. It's a term. You can't do that. You could do that. We'll do that second. Yes. It is. I love y'all's enthusiasm. We'll do that. We'll do that. We'll do that too. The easiest way to simplify this one. Yeah, cosine squared plus sine squared in the top is Papa Pid. It is 1. So you get 1 over cosine squared, which of course also simplifies to secant squared. And that's a little bit, I'll dismiss that. Okay. I actually am not going to have this one on there. Actually, this would be a multiple choice if I gave it to you like this, yes. Now, there's another way to do it. If you're heck bent on splitting it up, you could do that. you get cosine squared of x over cosine squared of x plus sine squared of x over cosine squared of x. That's legal. And now cosine squared over cosine squared is 1, and what's sine squared over cosine squared? Tangent squared. And now instead of Papa Pid, you use Baby Pid number 1, and you get secant squared. Now, I would memorize that. Anytime you see sine over cosine and you want to know what the derivative is, it's secant squared. What's the derivative of sine over cosine? Secant squared. Good. Now, the reason you want to memorize that is, of course, because sine over cosine is also known as what? Tangent. Ah, now we have just derived the derivative for tangent. The derivative of tangent is secant squared. We are going to memorize all 6 trig derivatives, and now we have 3, right? Let's review. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. And now the derivative of tangent without looking? Secant squared of x. Yeah. Now, tangent of x, you don't have to memorize this for tomorrow, but I know you already know it. Okay? Yeah. All right, let's talk about the test. We're done with the notes.